Welcome to our comprehensive video review on the safety and health considerations surrounding vehicle HVAC system. As we can delve into the intrinsic working of this system, it's crucial to recognize the pivotal role refrigerant play in regulating temperature within our vehicles. Refrigerant, while essential for heat transfer, can also pose environment and health challenges. In this video, we'll explore the evolution of automotive refrigerant, the transition toward environment-friendly alternative, and associated safety and health implications. Okay. Join us as we navigate through the landscape of refrigerant. From the phased out R12 to the widely adopted R134A and the more eco-friendly HFO 1234YF will uncover the global effort to address environment concerns, including international agreements like the Montreal Protocol and regional regulation shaping the choice made in vehicle HVAC system. Furthermore, we'll address critical safety and health issues related refrigerant leakage and microbial growth within this system by examining innovative solution and advance in sealing technology and air filtration system. We aim to shed light on how the automotive industry actively mitigating risk and prioritizing the well-being occupation. Stay tuned as we also discuss the responsibility of engineering technologies in ensuring compliance with environment regulation, promoting sustainable HVAC system design, and fostering a culture, education, and continuous improvement. Let's embark on this journey to understand intricacies of vehicle HVAC system and their impact on safety, health, and the environment.
Countries have enacted or adopt regulations such as the European Union's F-gas regulation, which aims to reduce the use of HGWP refrigerant.
Hi, I will now explain about safety and health solution in vehicle feature. Firstly, we need to improve sealing and leakage detection. Incorporating advanced sealing technologies in HVAC system and implementing effective leak detection mechanism can minimize refrigerant leakage. Secondly is air filtration system. Including high efficiency and air in HVAC system can help prevent the growth of mold and bacteria, enhancing indoor air quality and ensure occupant health. Refrigerant leakage. If there is a refrigerant leakage in a vehicle HVAC system, it can lead to release of potential harmful chemicals into the cabin. This will cause some exposure to occupant, may cause respiratory and skin irritation, posing the health risk. Next is microbial growth. Poor maintenance and inadequate cleaning of HVAC system can lead to growth of mold and bacteria in air duct. This can result in poor indoor quality within the vehicle, potential causing respiratory issues and allergic reaction amongst occupants.
Safety health solution in vehicle feature. Improve sealing and leak detection system. Issue refrigerant leakage can be addressed by incorporating advanced sealing technology in the HVAC system. Solution: implementing improved sealing material and incorporating effective leak detection system can minimize the risk of refrigerant leaks, enhancing both environmental safety and occupant health. Advanced air filtration system. Issue: microbial growth in the HVAC system can affect indoor air quality and occupant health. Solution: equipping vehicle with advanced air radiation systems such as high efficient particulate air filter can effectively capture and prevent the growth of mold and bacteria, ensuring cleaner air inside the vehicle and promoting occupant health.
For the responsibility as an engineering technologist. First, adherence to the regulation. Examples that updated on environmental regulation related to refrigerants and ensure compliance with standards to minimize the impact on the environment. Second, design for sustainability. For example, promote the use of low GWP and environmental friendly refrigerant in HVAC system design. Consider life cycle assessment to evaluate the overall environmental impact.
Educational and training. Provide education and training to maintenance personnel or proper handling and disposal of refrigerant, emphasizing safety and health protocol. Next, continuous improvement. Regular review and update HVAC system design and practice to incorporate the latest technologies that enhance safety, health, and environment performance.